Okay, a 0.25 gram sample of a compound that has CH and O undergoes a combustion to produce this much carbon and this much hydrogen. We need to find the empirical formula of this. So first thing we're gonna have to do is we're gonna have to find the moles of carbon and moles of hydrogen. So first we take the known grams of carbon dioxide and we divide it by 44.01 because that's the molar mass. And we get that by the molar mass of carbon, which is 12.01, and the molar mass of oxygen, which is 16, but there's 2 oxygen, so then we have to multiply it by 2, and we add them together to get 44.1. And then by that, once we do that, we get 8.325 times 10 to the negative third moles of CO2, and then we have to convert the moles of CO2 to moles of carbon with this conversion right here. And then we get the same thing because it's 1-to-1. And then now we have the moles of, we need to try to find the moles of hydrogen. So we do the same step. We multiply, we divide 0.15 grams of hydrogen, water, divide by the molar mass, and that's how we got the molar mass. And then we get basically the same amount of moles for both of them. And then we have to convert it to moles of hydrogen. And since there's 2 hydrogen per water, we need 2 on top and 1 on the bottom. And then we get 0.01665 moles of hydrogen. But we still need to find the moles of oxygen. So we have to find the grams of both carbon and hydrogen, and then we have to subtract it from the original starting amount, which is 1/4 of a gram. So then we take the moles of carbon and we multiply it by the molar mass, and we get 0.01 grams of carbon. And we do the same thing for hydrogen and multiply it by 1.01 to get 0.01681 grams of hydrogen. And then we add them together and we subtract it from the 1/4 of a gram that we started with to get 0.1332 grams of oxygen, and we divide that by 16 grams to find the moles of oxygen, and we basically have the same thing as carbon over here, carbon. Now we have to multiply it by the smallest number, and since these two are the same, the carbon and oxygen are the same, those are both the smallest, so they turn out to be 1. And then this hydrogen is, since we multiplied it by 2 over here, it started as basically the same thing as the other 2. It's gonna be 1.997, which rounds to 2. So then we have the empirical formula of CH2O.